Good morning and hello everybody. Today we are refining some Karat scrap. What I've got here is 1 gram of 23 Karat, 1.5 gram of 20 Karat, and 7 grams of 9 Karat. So we'll add these together, and now we need to inquart this with some silver. After a bit of maths, ChatGPT maths, which I'll put up here somewhere, it tells me that I need 9.5 grams of silver to inquart this material, and that's exactly 9.5 grams of silver. So next thing to do, get it all melted, corn-flake it, and then I can get it in some acid. Today I'm going to be precipitating the gold and the silver with ascorbic acid, vitamin C. So I'll get this corn flaked up and then we'll get outside, get it in some acid. So we have our inquarted gold, and to this I'm going to be adding some distilled water, and you always want to be using distilled water whenever you're dealing with silver. Now this is going to prevent silver chloride forming from using tap water. Now the nitric acid that I'm using is some of my own made nitric acid. I've got a video on how I make the nitric acid if you're interested. I'll leave a link in the description. But I'm going to start off with about 20 ml, and then I'll just increase as necessary. Right, now I'm going to time lapse the dissolving of the silver. While it's dissolving, I'm going to explain a bit about why we inquart gold and the benefits that it gives. Right, while we're watching the silver dissolve, let's talk a bit about why we had to do the inquartation in the first place. And you might be wondering, if I want the gold out, why did I add more silver to it first? It does seem a little backwards. But here's the issue. In Karat gold, especially higher carats, the gold atoms are packed so tightly together that they actually shield the silver and the copper inside. And if you was to just drop a 14 or an 18K ring into the acid would sort of eat the surface silver, but then it'll hit a wall of gold and it'd stop, and the silver would stay trapped inside. That's where inquartation comes in. The name comes from the 1/4 rule. We add enough pure silver to the scrap so that the final alloy is only around 25% gold and 75% silver. So by diluting the gold this much, we've essentially spread the gold atoms out. Now, if you look at the beaker, because the gold atoms are no longer a solid wall, the nitric acid can honeycomb its way through the entire piece. So it's dissolving all the silver that we added, plus the silver that was originally in the gold and the base metals, leaving behind a pure gold sponge, or powder if you add a bit too much silver. It's an extra step and an extra melt, but it's the only way to ensure that when we finally use the vitamin C later, when working with 99% pure solutions. And if you skip this, your final gold will be dirty, under carat, probably have some silver chloride in there. Okay, I'm going to get this rinsed off and then we'll have a little look at it. And again, I'm using distilled water for the rinses. Right, now if everything's gone to plan, what you should be left with is like a dark brown skeleton of the original flakes. Now these flakes are really easy to crush if you just put a bit of pressure on them, they crumble into a powder. So the next thing we need to do is get some hydrochloric acid on there. I'm just going to add around about 100 ml, and then I'll put a few drops of nitric in and we'll get this gold dissolved. Now you might have noticed that when I added the hydrochloric acid, a little bit of silver chloride formed. That's due to me not rinsing it properly. It's very minimal. It's not going to cause any problems. This reaction took around about 10 minutes. It's quite quick to dissolve just pure gold. Right, now the reaction's finished, what I'm going to do is I'm going to add some sulfamic acid. I'm going to do this while it's hot. This is going to remove any excess nitric acid, and it's going to remove any lead that might be present. It's going to convert it into lead sulfate, and it's going to precipitate out because it's insoluble. Now this needs to be done while it's hot, and as you can see it's foaming up. That's getting rid of all of the excess nitric. It's a lot better than urea. So I'll let this solution cool down and I'll get both of them filtered, and then we'll get ready for the precipitations. Okay, so as I said before, for the precipitations I'm going to be using vitamin C or ascorbic acid, just regular household vitamin C. I'll pop it in the gold first. Now this works in pretty much the same way as sodium metabisulfite. Precipitates a fine powder. Can also precipitate platinum group metals. I'll add a little bit more. That should do it. Now normally in refining we think of reagents as specialists, like you use SMB for gold, you use a copper bar for silver, but vitamin C is different, it's a generalist. Technically vitamin C is a strong reducing agent. It doesn't really care which precious metal is in the solution, it just wants to give the metal ions the electrons back. Once they get them electrons back, they can't stay dissolved anymore and they just turn back into solid metal. We've already seen what the magic it does on gold. So let's see what happens when we introduce it to the silver solution. It's the exact same reagent, but a completely different reaction to watch. Now, the first thing you're going to notice is the reaction's a lot slower than with the gold precipitation. And the second thing you'll notice is the silver is actually sticking to the side of the glass. It's sort of forming a bit of a mirror. But a bit later on, as the reaction carries on, the silver that settles out is really heavy and it clumps together really nice, and you can actually use that silver that settled on the bottom of the beaker to mix it round and sort of clean up the sides of the beaker walls. The solution's been sat for around about 5 minutes now, and it looks like all of the silver's precipitated. As you can see, it's clumped together really nice on the bottom of the beaker, and it's scraping beautifully off the side of the glass. I'll see if I can get a close-up for you. It looks just like cement silver. So what I'm going to do now is I'm going to redissolve this. I'm going to just give it a bit of a clean up with some distilled water, and then I'm going to redissolve it. Two purposes. Firstly is to prove that I have actually precipitated silver as a metal and not as a chloride. Silver chloride won't dissolve in nitric acid. And secondly, to highlight why I think this process might be beneficial to you. If you imagine that blue solution was some spent electrolyte from a silver cell, and you wanted to get your silver back out of that electrolyte without sticking a copper bar in there, leaving it overnight, you can add some ascorbic acid. It's going to take 5 minutes to precipitate your silver, and then it's going to take another 5 minutes to redissolve it. You've got fresh electrolyte. And as you can see, all that silver's gone now. That little bit of yellow colour is from an excess of nitric acid, which I'm going to see now when I dump it all back into that solution. You'll see a cloud of nitrogen dioxide. And there you go, that silver's now starting to precipitate back out. Another advantage is you can have one reagent for both your metals. You can get rid of the SMB. There's no smell to this, unlike the SMB, that horrible sulfury smell. I'm going to get these rinsed off, and I'll get them in some melt dishes, and then we'll melt them up. Okay, so here we have the gold, and here we have barely fitting in the crucible all the silver. I think I'll do the silver first. I'll get my torch ready, and I'll get these melted. There's our silver. As you can see, no impurities. Looks beautiful. Probably stand there, and then let's melt up the gold. And there you have it. There's our pure gold. 24 carat, weighing around about 5 gram. So there you go, 2 precious metals precipitated with the same reagent, a cheap reagent as well. If you found the video informative, give it a thumbs up, give it a like, drop a comment, and I'll see you on the next video. Thank you for watching.